Welcome to Grade 12 Physics AP, Mastering Newton's Law in Minutes. In this video, I am going to go over the solution to the quiz in our physics app. If you don't know what I'm talking about, you could look at our YouTube description to find the link in downloading our mobile app. This app contains all of the materials that we discussed, as well as the quiz for you to go over. So this first problem, again, like one of the examples that I have talked about on the previous videos, this problem you don't really need to worry about the vertical side, just because that acceleration is non-existent on vertical. It's because it would cancel out. It's at equilibrium. So we could just look at the horizontal case. So if we were to draw the free body diagram, we would know that on the 100 kilogram block, you would have the normal force, the gravitational force, as well as the force pushed by the person, which is 10 newtons, 20 degrees above the horizontal line. So, which means the force is directed 20 degrees below the horizontal line. Now, normal force, vertical of the 10 newtons, the vertical component of the 10 newton, as well as the gravitational force, would cancel out due to equilibrium. Let's look at the horizontal. Now we know that the x component of the 10 newtons, which is 10 cos 20 degrees, would equal to the mass of the block, which is 100 kilograms, times the x component of the acceleration, in which that is what we need to find. Now, you would see that after you isolate for your x component of the acceleration, we found out that it would equate to 0.094 meters per second square. So for question number 2, if we were to draw the free body diagram, it would look something like this, as you can see here. We could separate this into two systems, but you could also draw it like this. If you were to separate, you would isolate the 5 kilogram block with only one force, which is the tension, while on the horizontal, because you really don't need the vertical in this case. And the second one, you would have both the 18 newtons and the tension on the opposite sides. So after the free body diagram, we could look at the equations and how to solve this problem. So I'd like to let you guys know the end goal is to find the tension of the string that chains up between the 5 kilogram and the 2 kilogram. And you know that acceleration is the same because all of them are chained together and are moving in the same direction. So in this case, let's try to put t in an equation in which we could replace the second equation in a variable with this. So if we focused on the 5 kilogram block or the cart, we would see that t would equal to the mass times acceleration, which is 5 kilograms times a. So if we were to isolate a, we would have a equals to t over 5. Now if we look at the 2 kilogram cart, we would have 8 minus t would equate to mass of the 2 kilogram cart times acceleration. And we already know the acceleration is t over 5 according to our 5 kilogram cart equation. So if we were to substitute that in and isolate t, such as shown on the calculations on the right hand side of this screen, you'd see that tension would equal to 7.14 newtons. So question number 3. Well, this is the second type of problem that I was talking about regarding to the pulley problems, in which one weight is rested on a surface of something and the other one is suspended. So here you would have the 6 kilogram weight suspended on the table, and you got the 2 kilogram weight that is hanging on the edge. So if we were to look at the 3-body diagram isolating the 2 kilogram weight, we would see that if going down is the direction in which it will be, you could have the going down is the positive direction and up as the negative. And if we write it such that, we would have 2 kilograms times the acceleration due to gravity minus the tension of the rope equals to the 2 kilogram weight times the overall acceleration of the system. And if we were to isolate with the respect to the variable t, we would have t equals to 20 minus 2 times acceleration. Now we could look at our 6 kilogram. The 6 kilogram block has actually the friction force acted on it as well. So we know that the friction force is due to the normal force times the coefficient of friction. So the normal force in this case would be equate to the gravitational force, which is 6 times the acceleration of gravity. So if we were to write the equation, we would have the tension minus the friction force equals to 6 kilograms times the acceleration of the system. So if we were to replace the frictional force with what we just said before, the coefficient of friction times the normal force, tension minus 0.2 times 6 times 10 equals to 6 times the acceleration of the system. So if we were to isolate with putting the tension equation that we found from the 2 kilogram block into this, we would have 20 minus 2a minus 12 equals 6a. And if we were to isolate a, we would find that a would equal to 1 meter per second square. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.